Okay, we are here with Daisy to talk about evaluating expressions, and we're going to use order of operations to do that. Ready to go, Daisy?
Mm-hmm.
Okay, cool. So first let's talk about evaluating, and that's just a fancy word for finding the value. So let's go ahead and look at an example. Evaluate 3x for x equals 5. So 3x just means 3 times x. And when we say for x equals 5, that means we just put 5 in for the x in the expression. So that is 3x or 3 times x, which is just then 3 times 5. So what's 3 times 5?
15.
15, right? So that's our answer. So that's the value of 3x when x equals 5. We can circle that. Let's do another example here. Okay, evaluate 100 minus 2b squared for b equals 3. So this one's a little bit more complicated. So what we're going to do is we're going to do the same thing we did up above. And here we have b equals 3. So in the expression, wherever we have b, we're going to put a 3. Make sense?
Mm-hmm.
Okay, good. So let's go ahead and do that. So now we have 100 minus 2 times 3 squared, because it was 2 times b squared. Does that make sense?
Yeah.
Okay, cool. So let's go ahead and remember, though, that when we evaluate this, we have to use our order of operations. So Daisy, have you ever seen this thing right here, Pemdas or Pemdas? Have you ever seen one of those things?
Yeah.
Okay. Do you remember what they stand for?
Usually it's like Pemdas, so it's like parentheses.
Good. Exponents?
Exponents.
Good.
And then
The operations is the last one. So it's multiplication,
division,
addition, and subtraction. That's right. And these are in order, right? So whether it's a G, which stands for grouping, so that you can have brackets too as well as parentheses. Same thing though. Or a P for parentheses. You do the stuff in parentheses first. Then you do exponents. Then you do multiplication and division from left to right. And then you do addition and subtraction. Okay, make sense?
Mm-hmm.
Okay, so in this expression over here, now that we've written it out, what do we have to do first if we're going to follow our order of operations?
The exponent.
The exponent, right? So let's talk about the exponent. 3 to the second power, 3 squared, what is that?
9.
9, good. So let's rewrite this expression now with 9 in the place of the 3 squared. Does that look right?
Mm-hmm.
Okay, now with our order of operations, what do we have to do next?
Multiplication.
Good, multiplication. So we're going to multiply the 2 times the 9?
18.
18, right? So let's go ahead and rewrite it with 18. So now we have 100 minus 18. We're to just the last part, which is addition and subtraction. 100 minus 18, you might be able to do that in your head with mental math. Do you think you would do that?
92? No, 82.
82, good. It looks like thought 92 first, but then went to 82, and that's excellent. Very good. That's great mental math. So that's our answer for this. Make sense?
Mm-hmm.
Okay, let's do another one. Okay, evaluate 3 times the quantity 2a minus 3 for a equals 9. Okay, so what are we going to do to evaluate, just like we did in the top 2 examples? What's the first thing we do?
Put the 9 in for a.
Put the 9 in for a. Excellent. So we'll go ahead and substitute that 9 in for the a. And now what do we need to do, given our order of operations?
The stuff in the parentheses.
Good. And inside the parentheses, we follow the same order of operations. So what do we need to do first in there?
Multiplication.
Good. So what's 2 times 9?
18.
Good. So we'll rewrite this with the 18 there. Does that make sense?
Mm-hmm.
Okay, now what's the next thing in our order of operations?
Still parentheses.
Good.
So we need to do the subtraction.
Good. And so what's 18 minus 3?
15.
Good. All right, so now we have 3 times 15, and can you do mental math on that one?
45.
45. Excellent. Okay, good. So that's our answer there. So does all this make sense so far?
Mm-hmm.
Okay, now let's go up over to the other side and look at an example where we're going to be using formulas to evaluate an expression. So here we have what's called a rectangular prism. It's kind of like a stretched out cube, and it has a length, a width, and a height. Make sense?
Mm-hmm.
Do you remember what the formula for the volume of a rectangular prism would be?
The volume, length times width times height.
Yep, length times width times height. That's exactly right. And we can write that over here on the right-hand side. Okay, so what we're going to do is we're going to look at a problem that asks us to then evaluate for a certain length, width, and height. Okay? All right, so let's read this. Find the volume of 5 of these rectangular prisms that each have L equals 3 centimeters, W equals 2 centimeters, and H equals 4 centimeters. So it's very similar to our normal problem up here, except it says that there's 5 of them. So let's go ahead and write a formula for 5. See if this looks right to you. The volume, and then we put down here in this little subscript, we put 5 prisms, is equal to 5LWH. Does that make sense? Okay, good. So now let's go ahead and substitute the values in. So what do we put in for L?
3 or 15. Well,
3, yep, we can put in 3. And then for W?
2.
And for H?
4.
Good. So let's go ahead and write that. So does that all look correct so far? 5 times...
Wouldn't each of them be times by 5?
Oh, that's a good question. That's a really good question. If you think about the volume here, L times W times H, that's one of them. And then we'll multiply that by 5 times to get 5 of them. So actually, this is correct. We're going to multiply 5 times this whole thing here.
Oh, okay.
Okay? So now let's just go left to right here. So what's 5 times 3?
15.
Good. So then we can do that one. And then what's 15 times 2? That's a little mental math.
30.
30. Good. And then what's 30 times 4?
120.
120. That's excellent. Very good. So the volume of 5 of those prisms is 120 centimeters cubed. And I added in the units there because that's a volume unit, and we knew that each one of those was in centimeters, so the volume is in centimeters cubed. Make sense?
Mm-hmm.
Okay, great. So that's all about evaluating expressions. Good job.